So here I'm going to talk about section 2.1 of our book. So I'm going to give a little different example in the book so you can have two different examples to count on. Here we start talking about micro and macro states. So I'm going to write down micro state and macro state. And in order to understand what these actually mean, I'm going to give you the example. So let's say I have 1 penny and I flip it 4 times. Now the penny can give me two results, either heads or tails. So I have two outcomes. So let's make a table. I have 1 penny that is shown the first time, a second time, third time, and a fourth time. And I want to know how many times I'm going to get 2 tails and 2 heads. So I can start by saying the first time that I flip it, it's going to be a head, second time it's going to be a head, third time it's going to be a head, fourth a head. Then I flip it again, I get head, 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 tail, head, head, tail, head. And it can keep going on and on and on. However, these are not the ones that we're interested in right now, as they do not have 2 heads and 2 tails. So the one that have 2 heads and tails are going to be head, head, tail, tail, and then head, tail, tail, head, head, oops, sorry, tail, tail, head, head, um, tail, head, head, tail. Then we have tail, head, tail, head, head, tail, head, tail. As you can see, this one has 2 heads, 2 tails, 2 heads, 2 tails, 2 heads, 2 tails, and so on until the last one. So 2 heads, 2 tails, 2 heads, 2 tails. Okay, so we can count them, and they end up being 6. So in this case, when I say microstate, I'm talking about getting 2 heads and then 2 tails in this order, or 1 head, 2 tails, 1 head, or 2 tails, 2 heads. So each one of these lines is a microstate. However, when I just say 2 heads and 2 tails in no particular order, oops, that is a macrostate. Actually, in blue, so it sticks. So, what is the difference between a macrostate and a macrostate? A microstate cares about every single element. So, for example, it cares about the order. Well, instead, a macrostate cares about the overall. Result. So again, here for example, in the microstate, we have, for example, in order 1 head, 3 tails, that together make up, I'm gonna write it in black. Actually, sorry, I'm making it wrong. 1 head, 2 tails, 1 head, that together make up 2 heads, 2 tails. Or we can have 2 tails and 2 heads, and again together they make 2 heads, 2 tails. Or we can have 1 tail, 2 heads, 1 tail. But again, the microstate only cares about the fact there's 2 heads and 2 tails. As you can see, it's a little, the difference is not huge, However, once you finally get it, you get it. So what I like to think about is the order. The microstate cares about the order, while the macrostate doesn't. The macrostate only cares about the overall result, while the microstate instead cares about every single little particle, their order and what they do. One other thing that we're talking about is going to be our probability, which is equals to the microstate of our system over the total possibility. So, for example, we have a penny flipped 4 times. So it's going to be our all. It's going to be 2 outcomes at the power of 4 because we do it 4 times. Well, instead, our n is going to be equals to what? Well, it depends on what we want to do. For example, the probability of having 2 heads and 2 tails, for example, is going to be equals to what we just said. 2 over all is going to be equals to, we just said it's 6 combinations over with the power of 4. I'm just going to take the calculator. So 16, so we have 6 over 16 or 3 over 8. The probability of getting 2 heads and 2 tails, which is the most likely probability. However, one formula we can use for the macrostate is macrostate of n small n. I prefer actually using q. I feel like it's quite different. So we can just use this as, I'm going to write down the formula first, n factorial times q factorial times n minus q factorial. So what are the n's? Well, these are the possibilities. Actually, you know what? Let's write differently. Let's write this q as the outcomes, possible outcomes, total outcomes, and n is stated in a number of trials. It can be molecule or it can be number of times you flip the coin. So, for example, let's take our example 4. We have our macrostate of how many trials we have? 4 trials, and then we want to know actually possible outcomes, we want to say. So we had 2 heads, so 2 over here is equals to 1. Well, it's going to be equals to 4 over 2 times 4 minus 2 factorial. So 4 factorial is 24. Oops. 2 factorial is 2 times 2 factorial. Yeah, which is equals 24 over 4, which is equals to 6. And again, the possibilities of having 2 heads or 2 tails, it's dependent, whatever you want to count, in 4 trials. Well, so the combination we can have with 4 trials to have 2 heads or 2 tails is 6. The possibility that will be oops, will be 6 over, again we said 2 to the power of 4, so 6 over we said it was 16, so 3 over 8. Again, we proved that again. There we go. This is quite easy, I like to say. It's not too complicated. However, you definitely need to try hard enough. You need to learn the difference in microstate and macrostate. But after you learn these two, you should be good.